In this video, we're going to solve systems of equations algebraically. I'm hopeful that you've already looked at how to solve a system of equations using graphing. The reason why is because we believe that it's important that you know that when you graph two lines, when you have a system of two equations, the answer that you get, the solution to the system of two equations, is the x and the y value where the two lines cross. Now, why is that the solution? Well, because it's this x, and this y value are the only. It's the only place where you have an x and a y value that's true for this line and for this line. Anyways, let's take a look and see how we can solve for that stuff and find it algebraically. This first method of solving algebraically we're going to look at is known as solving by using elimination. If you go on the internet and you look at other videos, you can also search for solving systems of equations by addition or by multiplication. But ultimately the goal here is we'd like to eliminate one variable. We'd either like to eliminate the x's or we'd like to eliminate the y's. And if we can do that, then we can solve for whatever's left over. So in this case, what I'd like to do is I could do either one. I could get rid of the x's or the y's. And in fact, I might leave this as an exercise for you to try to get rid of the other one and solve the same problem and see if you can come up with the same answer. I'm going to go ahead and try to get rid of the y's. And the way I'll do it is I need to have a positive number in front of the y and a negative number in front of the y, and I need those two numbers to be the same so that they are opposites so that they cancel out. So what I'll do is I'm going to multiply this first equation through by 5. If you recall, it's perfectly legal for me to multiply an equation by some number as long as I multiply the right side and the left side by the same number. And when I do that, by the way, I'm going to mark this equation. I'm going to call this equation number 1, and it'll make it a little bit easier for me to talk to you guys about which equation I'm working on. So I'll just recopy equation number 1 with the multiplying. So I'll go ahead and multiply it all out, and when I do, I get 25x plus 20y equals 50. And then for equation number 2, I'm going to go through and I'm going to multiply that guy. I want to get a negative 20y because I want to cancel this y out. So I'm going to multiply equation number 2 by positive 4. And if I multiply the left-hand side, I also have to multiply the right-hand side. And when I do that, for equation number 2, I'll end up with negative 12x minus 20y equals 28. Now, what my goal is now is to add these two equations together, and when I do, I'm hopeful that I'll get rid of one of the two variables, either x's or y's. Now, I would so love it if you copied the notes down and if you practiced in class exactly the way that I'm presenting it to you. Notice how I put the parentheses around both sides and then I put the plus sign out in front. It's perfectly legal to subtract as well, and I like to write things out so that I can remember what I'm doing. As I go through and I add these two terms and these two terms and these two terms, I want to remind myself that I'm adding in each case. It's too easy for students to just cancel and then forget what operation they're trying to perform. So anyways, we're going to add 25x and negative 12x, and when we do, we end up getting negative 13x. And when we add 20y plus negative 20y, again, remember we're adding, we're not subtracting. Even though it looks like 20y minus 20y, we're adding these two together, we get 0. If you look it up on your magic spell sheet, you'll see that when you add opposites together and you get 0, we call that the additive, let's see, actually that's the inverse additive property, where you the additive inverse, where you add two numbers that are opposites and you get a 0. And let's keep going here. So I'm still going to add the 50 and the 28, even though it looks like I just subtracted. Remember, I remind myself that I'm adding. So I'm going to add and get 78. And I'm hopeful that I can divide 78 by 13. Doesn't always work out that way, but I'm hopeful. So let's try that one out. It looks like we're in luck. 78 divided by negative 13 is negative 6. So yay, we love that result. Now I'm going to circle the result x equals negative 6 because I'm not done yet. That's one part of my answer, so I just circle it. In the end, I'll box my answer. So now what I need to do is I need to figure out what y is since I figured out x. So now I can use either equation 1 or equation 2. And I think I'm going to use equation 1 because there's less negative signs. So in equation 1, what happens is this. We will just substitute x equals negative 6 in for x here. So we write 5 times negative 6, and then we'll add that to plus 4y equals just 10. Remember, we're using the original equation. We're not doing the multiply times 5. So this gets me 4y equals 10. And this is negative 30, so I'll add it to both sides. Positive 30 to plus this means 0. Positive 30 over here gets me 40. So that gets me 4y equals 40, and so therefore y equals 10. Yay! That is a cool result. I'm very happy with that. So in doing that, I now have my x value and I have my y value, and now I can put that together and box my answer. And my answer is going to be negative 6. Oops. Negative 6, comma 10, and I'll go ahead and I'll put that in parentheses. And this is an answer that I can go ahead and box. This is legitimately the final answer to my problem. I've got my x and my y, and that is the point where these, if I went to graph this is a line and this is a line, they do cross, and this is the point where the two lines cross. So we'll look at a couple other examples, but I just wanted to get you started with this.